Welcome to this session. Myself K.Senthilvadivu, Assistant Professor of Computer Science and Engineering Department, Erode Sengunthar Engineering College, Tamil Nadu. Under the AICTE PRERANA scheme for preparing SC/ST student higher education gate, I'm going to handle a topic OSI layer and TCP/IP protocol suite in computer networks. The gate syllabus for computer networks. First, in layering, OSI and TCP/IP protocol suite, basics of packet, circuit and virtual circuit switching, data link layer, and then routing protocols, transport layer, application layer protocols. So in this session, I'm going to handle in the first unit OSI layer and TCP/IP protocol stacks. Yes. First, what is layered task? In our day-to-day life, we consider simple communications between two persons through the post mails. How the post transfer, post communication from one person to the another person means sending a letter. For example, a person sending a letter to his friend through the post. How this transfer takes place? First, the person write the letter and envelope it and drop it into the mailbox near to him. Then the letter is carried from mailbox to the post office by the postman. After that, based on the address, the letter is delivered to the post office of that nearest place. Then from the post office, the letter is carried to the mailbox. Then from the mailbox, the person's friend retrieve the letter and open the envelope, read the letter. This is the traditional method of simple communication through post office. So we consider this as an example for network communication. So first developed standard model is OSI model, Open System Interconnection model. Was developed in 1947 and it is standardized by the organization International Standard Organization ISO, and it was first introduced in the network in 1970s. So in OSI model, it is just a reference model. It is not in use now. In this conceptual model, the communication between two devices is divided into several layers by combining simple components to make the communication simpler. So there are 7 layers in OSI model. First layer is application layer, then presentation, session, transport, network layer, data link layer, and then physical layer. So let me see how the communication takes place between two devices through the 7 layers. The application layer is the one-on-one layer that the user can directly interact with those layers. Unlike that, Physical layer is the only layer that can interact with the physical medium. So these are the intermediate layers. So this layer is divided into upper layer and then lower layer. So in the lower layer, the communication is node to node communication. Okay, then what is node to node communication? So the device A want to communicate with the device B. So it transfers the message through the 7 layer and the message travels through the physical communication medium. In physical communication medium, there are a lot of intermediate nodes. There are a lot of switches, routers, and then servers like that. So each intermediate node have this 3 layer: physical layer, data link layer, and then network layer. So communication between intermediate node and the sending node is a node to node communication, and the communication between intermediate node to the next intermediate node is again a node to node communication. So likewise it goes on up to the message reaches to the its destination. So this is called node to node communication. In transport layer, it is a process to process communication. So we can discuss it later. Let me see each and every layer in detail. So as the layer moves down from application layer to the network layer, the data are encapsulated in the next layer. A packet at the application layer is encapsulated at the packet in the presentation layer. Means the packet at level 7 is encapsulated at the packet at level 6. The whole packet at level 6 is again encapsulated at level 5, and it goes on. Likewise, at the receiver end, the packet is decapsulated at each stage. So now we see each and every layer in detail. In physical layer, it is the lowest layer. It retrieves data from the data link layer and it converts the data into bits. Then it transfers the sequence of bits through this transmission medium, and at the receiver end, it is the first layer that receives the data. Physical layer is the one and only layer that interacts directly with the physical medium. So the physical layer is responsible for movement of individual bits from one host to the next host. So in physical layer, the transmission mode is decided at the physical layer. It means simplex, half duplex, or full duplex. And the topology is defined at this layer only. It means like mesh, star, ring, bus, or hybrid topology. And the connection may be of point to point connection, multi point connection, and the data transmission rate is also defined at the physical layer. The bits are synchronized from sender to the receiver. And the next layer is data link layer. The data link layer retrieve data from the network layer and then make it into frames. Then it add the headers and then transmit the data to the physical layer. The responsibilities of data link layer is, first one is framing. It means the data link layer divide the given data into set of frames. In data link layer, the physical addressing are done. The physical address means the address that are in the NIC card, network interface card. The error control and flow control mechanisms are implemented at the data link layer. And the access control are also implemented at this layer. It means when two or more devices are communicate at the same link, data link layer has the responsibility to determine which device has the control over the link at the given time. At the receiver end, the data link layer is the second layer. It gets the data from the physical layer and packet the bits into frames and give to the network layer. The data link layer is responsible of moving of frames from one hoop to next hoop. Physical layer is responsible for moving of bits from one hoop to another hoop, and like that, data link layer is responsible of moving of frames from one hoop to the another hoop. So hope to hope delivery. It is also called as end-to-end delivery. So in physical and data link layer, the communication is hope to hope or node to node delivery. So these are end systems A and D, and B, C, E are intermediate nodes. When the message travel on the network at data link and physical layer, it must be of hope to hope delivery. And the next layer is network layer. So in network layer, the data transmission takes place from host to host. In network layer, it receives the data from transport layer and then it split the data into packets, and the output of network layer is given to the data link layer. The data link layer do the logical addressing and routing of data in the network path. So it is responsible for delivering of individual packet from source host to the destination host. First responsibility of a network layer is logical addressing. Logical addressing is an in other words, it can be said as IP address. It is an unique address for each individual machine at the communication through the internet. Then it routes the packet from one node to the another node, or from the intermediate nodes, means switches, routers, up to the final destination. So the network layer is responsibility of delivering of individual packet from host to host. So from network to network is the host to host delivery from A to F. Next layer is transport layer. The transport layer is responsible for process to process delivery of the message. So in network layer, the message is delivered from host to host, but it is not enough because at a single time multiple processes are running on this system. So we have to a process is an application program running on a host. So the transport layer is responsible for transferring the message from one process to the another process. The address referring at the transport layer is called service point address or port address. The transport layer receives data from the session layer and then divide the packet into segments. Then it gives input to the network layer. At the receiver end, it is a reverse process. So it gets data from the network layer and unpacket it and transmit the data to the port. So transport layer is responsible of delivering message from one process to another process. So in a system, there are multiple processes running at the same time. So if process A want to communicate with process some process B want to communicate with process D, then it can be delivered properly by the transport layer. So in network and data link layer, it is a node to node delivery. Sorry, in physical and data link layer, it is a node to node delivery, and in network layer, it is a host to host delivery, and at the transport layer, it is a process to process delivery. In session layer, it gets data from the presentation layer and the session layer is responsible for dialog control and synchronization. So, for example, dial-up control, if two systems want to communicate with each other in a half duplex or full duplex mode, the dial-up voice or video or audio, the dialogue has been synchronized and sent in an order, and the receiver has to receive the dialogue in the same order. So the synchronization has been done between the sender and the receiver by transferring the stream of data. So dialogue control and synchronization is the responsibility of session layer. In presentation layer, it deals with the compression, encryption, and transition of data. So compression of data means reducing the number of bits in the information to sendable size. So the information may be of text, audio, or video. And then encryption. Encryption means sender transfers the original information to the another system that can be encrypted. It means to another form, because unauthorized, to avoid unauthorized access, and the reverse process decryption is done at the receiver end. Next is application layer. This is the only layer through which the user can interact. So it is responsible for providing service to the user. So there are a lot of protocols, file transfer protocols, and then email services are provided at this layer. Accessing of files, messages, and interact with the network, or the human interaction is done at the application layer. This is the first layer in the sender, and it is the last layer in the receiver. So through which the user can enter the data into the network layers, through which the user can get the data from the network layer. It does lot of services, mail services, directory services, file transfer and management, and network virtual termination. These are the responsibilities of applications layer. So the overall view of layers. So in each layer, the data referencing of data is different. That is also called as protocol data unit. In application layer, it is a data. In presentation layer, it is a data. In session layer, it is a data. But in transport layer, it is an segment or datagrams. In network layer, it is a packet. In data link layer, it is on frames. In physical layer, P2 is bits. Each layer has a unique functionality. So in application layer, it allows the user to interact with the network. In presentation layer, it encrypts the data. It means it provides security to the data, and it compresses the data for easy transaction. And in session layer, it establish, maintain, terminate the connections. And in transport layer, it provides process-to-process message delivery. And in this layer, the connection has been selected like connection TCP connection or UDP connection. It means reliable, unreliable connection. The connection through which connections the transmission has been taken place or chosen at this layer. The network layer is responsible for host-to-host delivery of packets. In data link layer, the packets are organized into frames and it is responsible for hope-to-hope delivery. In physical layer, it is the only layer that interact with the medium. So in physical layer, the data are transmitted as bit. So in sender, from application to physical layer, the transaction takes place. At the receiver end, physical to application layer as like reverse process. So that's all about OSI layer. So it is only a conceptual model. So the real one implemented is TCP IP protocol suite, transmission control protocol and internet protocol. So it has 4 layers. So first one is a physical layer, and then network layer, transport layer, and then application layer. In this, the application presentation and session layer combined into application layer, and then transport layer is like a transport layer, then network layer, and data link and physical layer are combined as one. So here we are saying 5 layer, where the physical and data link layer are combined into one. So let's see inside the TCP IP layer. In physical and data link layer, it is responsible for a host to network communication. So it is the lowest layer in the TCP IP protocol. And the next one is network. In network layer, in this layer, physical addressing or referred. In network layer, logically addressing or referred, where the protocols like internet protocol, ARP address resolution protocol, RARP reverse address resolution protocol, and then ICMP, IGMP, like that, this protocol are used to make host to host delivery. And in transport layer, it is a process to process delivery, and then where the protocols TCP, UDP and STP were used. TCP is a connection oriented and UDP is a connectionless protocol, and STP is a another one. Then session, presentation and applications are combined into application layer, where several protocols are used to provide service to the users: SMTP, FTP, HTTP, DNS, SNMP and Telnet. Let's see each of them in detail. So in each layer, different addressing format or referred. Physical addressing, logical addressing, port addressing, specific addressing. So the first layer, host to network, where the physical and data link layer are combined into one. So where there is no specific protocols, where the physical address or referred. The physical address means it's an address uniquely defined network interface card at every CPU. Next one is network layer. In network layer, the responsibility of network layer is host-to-host delivery of message. In this layer, the different protocols like ARP or ARP, ICMP and IGMP are used. First, IP, Internetworking Protocol. So this is used to transmission of data, and then address resolution protocol. So it is used to convert logical address into physical address, and reverse address resolution protocol. So that is used to convert a physical address into logical address. Then ICMP, Internet Control Message Protocol. So it provides a gateway to send notification of data gram problems back to the center. It means it provides error reporting message and querying. Next is IGMP, Internet Group Message Protocol. So this is used to communicate among multiple hosts. It means a group of transition simultaneously can be achieved through the IGMP protocol. So the next layer is transport layer. So in transport layer, there are two main protocols. First is TCP and then UDP. Transport layer is responsible for process to process delivery. It refers the address is port address. So in each system, there are a number of ports. So the process can communicate with the process on the other host through this port address. So first one is UDP and then next one is TCP, or first UDP means user datacam protocol. So it is a connectionless and unreliable protocol, and then TCP is a transmission control protocol. So it is a connection oriented protocol and is a reliable one. So what is the difference between UDP and TCP means? In a UDP, we never get an acknowledgement of whether the data is delivered to the receiver. So the sender won't worry about that. But in TCP, we first establish an communication. After that, we send the data. After sending data, getting the acknowledgement, the connection has been disconnected. So here, the connection is reliable. So then SCTP means Stream Control Transmission Protocol. So this is the newest one used for communication of message like voice or video message. Provides best feature for that. Next one is application layer. So in this layer, the session, presentation, and application layer are combined into one, where many protocols were defined like um, SMTP, and then simple mail transfer protocol, telnet, DNS, HTTP, FTP are the different protocols used at the application layers to provide services to the users. Where specific address or used address layer, it means like email address, URL, universal resource locator, are used at the application layer. So when we enter, for example, google.com at the browser, it's a specific address, then that is converted into logical address, then to physical address, then it communicates to some particular port number to the server. So let we see examples of each addressing. For example, for specific address google.com or unicity.edu, like that. So for physical address, it is an example. It is a 6-byte address or 12 hexadecimal digits. It is an hexadecimal digits of divided into 6 parts, means 6 bytes. Each one is 1 byte. Totally, it is 48-bit address. So consider an example. A node with physical address 10 sends a frame to a node with physical address 87. The two nodes are connected by a link, means through LAN bus topology. As the figure shows, the computer with physical address 10 is the sender and computer with physical address 87 is the receiver. So 10 source address and destination address 87. So in a data, both source address and destination address are mentioned. Likewise, in receiver, the source means its address and the sender's address, physical address are mentioned. So example of physical address, how it's like. Next one is IP address. Example of IP address. A part of internet with two routers connecting three LAN. Each device has a pair of address, it means logical and physical address for each communication. In this case, each computer is connected to only one link and therefore has only one pair of address. Each router, however, is connected to the three networks. Only two are shown in the figure. So each router has three pair of address, one for each connections. So each one has an IP address. Likewise, each device has an physical address. While communicating through the LAN, the physical address from source to the destination can change, but the IP address remains the same from source to the destination. So see here, the physical address 2010, here 2010, here 3399, and here 3399. While the LAN changes, the physical address is 9565, means total address, and again the LAN changes, it means 9566. But the IP address of sender remains the same through overall network up to reach the destination. port address. Port address is a useful at the process to process communication stage. The example of port address, it is an integer. 16-bit integer means 2 bytes as one port number. It is a simple number. So while communication, so A want to communicate with J, so A's port number and J through which port A can communicate with J. So that port number, and then system A IP address and receiver IP address. After that, physical address are added at the each layer, and the data is transmitted to the internet. So the port address are added at the transport layer, and then in network layer, logical address are added. Data link layer, the physical address is included at the in this scatter session. So physical address of sender and then receiver. After that, the message is transmitted through the internet. So when the receiver receives the data, first it's the header and unpacket it. After that, in network layer, it checks for IP address. After that, in a transport layer, it checks for the port number through which the data has to be sent to the process finally. This is the overall communication takes place at the TCP and IP protocol. So thank you.